And it seems that we should be online. So, hello everyone. Welcome to our first Cloud Beer Brno with today's topic, serverless and cost optimization. My name is Kristina. I'm from FlowUp, and today I will be your moderator. So I hope you will like the event and everything will go fine. I also have here today's speakers. So let's welcome them now. So our first speaker of today will be Václav Lukáš from ACTUM Digital, who is going to speak about serverless, when and why to use it. Our second speaker is going to be Marek Bartík from pipetail, whose talk will be eRouška Backend, serverless golang to serve 1.5 million plus users, expensive or not. And our third speaker is Malina, who is from FlowUp, and who, like 10 seconds ago, changed his topic a little. So the topic is going to be developing on serverless from the cost perspective. Before we start with the talks, I've got also several information for you. So at the end of each of the presentations, there's going to be a Q&A. So, oh, hi, Stepan. There's going to be Q&A. So please, if you have any question on the topic, just write it to the chat that is next to the stream window on YouTube. Be also aware of that we've got around 30 seconds delay between you send the message and we get it. So don't worry, we are going to answer you. It's just going to take some time. Each time we will be answering the question, we are going to put it into the stream window, so everybody will know what we are speaking about at the moment. After the last Q&A, there is also a possibility to open a Google Meet or something like that and have a further discussion where we can actually talk to each other. So if you are going to be interested, no problem with that. Okay, I think that I said it all, which means that I'm happy to introduce to you our first speaker, who is Vašek Lukáš from ACTUM Digital, and Vašek is going to speak about serverless and when and why to use it. So Vašek, the stage is yours.
So, hello everybody. Thank you for either connecting now or someday in the future watching this video. Thank you, Kristina, for the introduction and yeah, for the possibility to talk here. I'm not going to prolong it anymore further. So, my name is Vašek. I am a cloud solution architect in ACTUM Digital, and right now, most of the time, I spend is a great topic of the Center of Excellence for Google Cloud. And today I would like to tell you something about some general information and yeah, serverless approach. So probably the $1,000,000 question here for maybe somebody already knows the answer to what is serverless. Well, serverless is a cloud computing execution model in which the cloud provider allocates machine resources on demand, taking care of the servers on behalf of their customers. Well, if you fell asleep while I was telling the definition, then I really don't blame you. There is a lot of definition going around with serverless, which might make it seem a bit complicated. And to be honest, I don't think it really is. So let's put it that way. Let's make it simpler. So serverless is when servers is somebody else's problem. Pretty much simple, right? So somebody will provide us with a serverless service, but what does it really mean? What do I get for that? And what do you get with serverless is a service that where you pay as you go. That such a service scales automatically. It can scale to 0, and there are no servers to manage. All of these things combined together have a great impact on your costs and how can you reduce such costs. So I will also talk today, just in a couple of minutes, about how exactly and where the potential is. Sometimes it's not really about the serverless service, so to say, but I can feel that it's a serverless approach. For example, imagine you have a storage and you need to keep a great amount of data that you don't necessarily need to be accessed frequently. That is a key point here. So after some time, you go and archive such data on a less costly solution. But this requires you to keep track of the data that you want to move to such a less costly solution. And yeah, manually go there and do some stuff. However, if you use some serverless or some serverless thinking or approach, then you can use such features. For example, lifecycle management, where simply say, put this file into an archived storage solution when nobody is accessing it for, I don't know, a year. And then suddenly, without you touching anything, you have a solution where you can save up to 80% of the standard storage cost just by, I don't know, clicking a couple of buttons and really using the cloud potential there. So let's take a look. Of course, serverless has pros. Serverless has its cons. So let's go through the pros now. As I said, pay as go. What it really means is that you only pay for what you use. And what I'm trying to say, you can pay as you go, but you shouldn't go too far, because it can backlash a little bit when there's a sudden peak in the traffic, and then it will scale up, but you will have to pay for that. So if you mess up the infrastructure, sort of mess up, then you will pay a lot of money. But again, there were some stories where you would have to pay thousands of dollars just by sudden peak or unluckily processing terabytes of data. But there are, of course, some stories like that, but really the cloud vendors are the nice guys here and can give you the money back if they really see that it was a mistake. But just a heads up for that, and be careful what you are using the serverless services for. Yeah. So there is a great deal and great topic with the cost reduction. Actually, the whole topic of this event is a cost reduction, and from my point of view, the most expensive thing about, in general, developing things on cloud are actually the people. So with serverless, there is no management of servers. There is no maintenance. You can deploy the services much faster, or the application deployment is much faster. So you save a huge amount of money there. Well, eventually we will hear that from Marek and Petr today, how exactly. There is a great deal of automatic scaling that comes with a serverless, because what it is that you don't need to configure the scaling. The serverless service does it for you. You basically get the compute on demand. So you don't need to specify the scaling setup, which is an usual DevOps task. So, and as I said, really the people are the most pricey thing about the whole development there. And yeah, speaking of people, it is no ops. Well, I probably shouldn't say no ops. It's low ops. There is, of course, some operation there, but the bigger part of it that comes with the management of servers, it really gets easier when you try to use the serverless. And yeah, you can also have less overhead, which again will introduce great cost reductions. With that in mind, there are some use cases that you might consider to use serverless for. Such a really obvious one is the batch operations. With batch operations, that is a use case, is an idle use case for the actions that don't need to necessarily happen immediately. For example, you get that some IoT data, and then you need there's some operation needed above the data. The best you can do here is just set up some cloud scheduler, pops up, or a cloud function that will run every day at midnight. And not only you don't have to trigger it manually or have a running server permanently that would set up the trigger or on the function, but also you only have to pay for the time or the duration when the function and the connected services are running. So there is no extra cost for idle machines or something. Moving on to the simple backend logic. So with serverless, you can easily set up a basic backend logic without writing almost any code. How? Well, I'm glad you asked. Basically, you need to move some piece of information from a customer to a database and then display it in a graph, for example. The easiest way is to set up some consecutive serverless services like PubSub to publish a message that contains the information to a certain topic, then use Dataflow to orchestrate where the information goes, for example, to BigQuery for some as a data warehouse to do some analytics upon, and then use Data Studio to display the data that will be fed from the BigQuery. The great thing about this is that it can scale massively without you touching it. You will only have to pay for the queries run and the messages sent. No over provisioning, no issue with demanding peaks in the traffic, nothing. Spoiler alert, that's not completely without code, of course. You will need to write some SQL query, but no worries, it's not a big deal, really. And last but not least is a topic of task automation and event-triggered actions. So another great way to use serverless services, and more specifically, cloud functions, are event-triggered actions for automation. So in some cases, it can speed up your CI/CD pipeline pretty massively, and it can make it less error-prone, and you can mitigate the risk pretty much. So just now we are helping a customer to automate the flow when a new piece of software is released. There is a further logic connected when the new version of their software is released. So previously, the logic was done manually by going into the file on a server, editing some stuff, and hoping for the best, not to make a typo. So very dependent on the person, very error prone. With the new integration with the serverless services like Firebase Cloud Functions, they will automatically trigger the consecutive functions based on the new version of the software released. Nobody has to do anything manually. Thus, you are saving the time, and time is money. In cloud, even more so. Moving on to things that are probably the downside of the serverless services. But when it comes to the cons, it's not really black and white. In some cases, you just need to act accordingly and still sort of utilize serverless correctly. But let's take a look when you might struggle with, or where you should what you should pay attention to. So we have latency here. You might ask, how is there latency when there should be no server? And again, a great question. There are servers, of course, but you don't necessarily have to see them. You don't have to worry about it. You don't have to manage them. The thing with the latency is that it is connected to the pay as you go. So you only have to pay for the functions or for the services that you use. And when you are not using it, you're not only you're not paying for them because the services are turned off or the instances are turned off. So idle instances might introduce some additional latency when you finally decide to invoke them. So probably just a heads up here, there is an important question: is it necessarily a problem? Does the latency somehow interfere with my business case? Does it need to be almost real time? And if not, then no problem. We can go with the serverless. I think I can give you two tips and tricks how to approach that. Really keep your functions, and again, I'm talking about the function as a service here. Keep your functions focused and simple. You pay for seconds of megabytes, and you need to pay attention for how long do these services run. If you can make it shorter, you will save the money. And then again, language of choice depends. Python, for example, might be faster for your solution than Java. And again, if you can make it simpler and it will execute faster, then you will save up some money. Let's move on to the vendor lock-in. That is a great deal and great issue that is mentioned a lot when it comes to the serverless. And here, I think, comes the serverless thinking at hand. I'm not saying, well, to be honest, every choice of technology is a sort of a vendor lock-in. So in the end, you need to prepare for an easy migration if that indeed needs to happen. But yeah, for such instance, try to make use of, for example, Cloud Run. But what it does, I think Petr will tell you more about that today. If you are from IT, which I think you are, most of you, then you have probably heard about the denial of service. What you can encounter here with serverless even more so is something called denial of wallet. So the downside that is actually downside of the pay-as-you-go and automatic scaling model. So you might scale until you run out of money. And again, that is just a heads up to pay attention to how your infrastructure is set up. You can set up billing alerts, but they don't save you. They might warn you that you are going to spend a huge amount of money, but with great scaling comes great responsibility, so to say. And again, last but not least, you might not be limited by the scaling of the service on your side because it scales automatically, but there might be a limitation on the other side where you need to communicate with a API or something, and there might be the communication because it cannot scale just as much as your serverless service can. So again, it's just a heads up to pay attention to the whole environment where the serverless lies. And again, as with the pros, with cons, we have some use cases when not to use it. So with that in mind, let's see the constant workloads. You can have the use cases where they demand that they are high demanding workloads. You probably need a lot of allocated memory or storage. I'm not saying you cannot use serverless on that, but it's going to cost you arm and leg to make it happen. So probably either simplify it or choose perhaps a serverless solution. Speaking about the scaling, there is actually a limitation on the vertical scaling. When we are talking about scaling, we can talk about two types, vertical and horizontal. While there is no problem to add more instances to cover up your peaks and process the incoming data, there is actually a limit. When it comes to serverless, there is actually a limit on the vertical scaling where you need, for example, gigabytes of memory and hundreds of CPUs. Then it's probably not only hard, but perhaps not even possible. So, and then again, if you have a complex code and you have a lot of dependencies, libraries, or you're in need of in-depth monitoring, then you might look again for another tool, or perhaps some serverless tool that is solely focused on that, but probably another solution at all. Because with serverless, you are paying exactly for not dealing with the management of the service and in-depth monitoring and pod handling and stuff like that. The last one is, I think, not a downside, but just to remind you that when it comes to cloud, it's really important to understand the bill that you get from your cloud provider. It's not only about the service itself. So, for example, you have a use case and you want to use it, and you see, okay, I can use 2 million of invocations of a cloud function, and it's not going to cost me anything. Well, it's not like, as I said, it's not only about the service itself. You have to pay attention to other connected services like load balancers, logs, APIs, and that might introduce some additional cost to your solution. So you have to pay attention to that as well. When I was talking about the serverless in general, I might have mentioned a lot of times services that can be recognized as function as a service, but serverless is much more of that, much more than that. Basically, when you come across some fully managed service that scales to zero, where you pay as you go, there is no management of servers, you might just as well call it serverless. On the other hand, managed does not mean necessarily serverless. So for example, if you have a Redis database, it can be managed, but it won't scale without your actions. So just to keep in mind for that, just a food for the thought. And yeah, I talked about the functions, the cloud functions, AWS Lambda. Both of them are great solutions for that. But we can also find serverless services like great tools for analytics, like BigQuery, GC storage, or the serverless integration or implementation of containerized application like Cloud Run. And there is much more to that. And I just want to bring or highlight this one here that Google announced a couple of weeks ago, I think, or maybe perhaps even days. There is a GKE autopilot that is now generally available, which is a fully automated Kubernetes platform where you can run your containerized applications. And I'm really excited to take a look into that, because I really think it's going to be a big deal, as it takes away some sometimes unnecessary management that comes with the Kubernetes. I would like to end up with the table, pretty much simplified table of a certain use case that helped me finally realize where is the potential, where is the potential of the serverless. So from what I've said today, serverless is all about things happening automatically. You can innovate faster, you can maintain cheaper, but both of these aspects have a common factor, and that is time. And well, time is money. We all say that, but in cloud we not only say that, but we also pay for that. So you have a functions that runs for minutes. Yeah, no problem. The cloud can do that. You store too much data on a standard storage. Well, you can do that, but you are going to pay for that. Or are you processing terabytes of data? Well, be my guest, but pay up. And what's worse, so to say, people cost money. So if you can do anything that will speed up the development or take away the maintenance cost, do it, because costs on development, maintenance, or even hiring people are eventually the biggest costs. So when looking at a table, please bear in mind a certain solution that can be deployed on serverful, and as well as serverless. With the deployment, it can take up to 30 days with, I don't know, 3 developers of mid seniority, but in serverless, just in 10 days. The same thing is here with the upfront cost. You can say up to 25,000, and in upfront cost, you have to pay the overhead, you have to pay the hardware, you have to pay the infrastructure there. So again, big savings on the serverless side. And of course, when it comes to monthly costs, it's not only about the infrastructure, but you have to pay for the people that maintain the solution after all. So if you take a look on the most top right column, there we can see for that certain use case, we can save a big amount of money. Sometimes serverless infrastructure might be even more expensive than the serverful infrastructure, but the time spent on the deployment and maintenance is the key cost optimization. And what to really end up with is serverless, I think, is great because of the easy adoption and fast deployment. With that, you can create the MVPs really, really fast and reduce the time to market, which is sort of a not really development thing, or developer doesn't really care about it, but there is a great business value when you can be the competition to the market. So where you can leverage it, that's really up to you. And it's not only for the startups. I can see big projects that can utilize the cost-effective approach with the serverless. And I'm not here to talk about that. I think more about that from Marek and Peťo today in their presentations. So thank you for the attention, and really get in touch if needed. And I'm really happy to talk about whatever you need.
Okay, thank you very much, Vašek. And we've got some questions for you in the chat. So I will now display the first one, which is by Michal. And the question is, which language fits best for serverless as API?
Well, I think the main cloud vendors are investing huge amount of energy into developing more and more. So right now, or previously, there were only some languages for that. But as the time goes, we can see that, for example, there's I think in some beta version there's a C#, there's Java. So I'm not sure if I can say what is the best fit exactly, but you are looking at the most I don't know, when it comes to the processing. I would say JavaScript or Python might be really fast. But again, I think the worst answer that you can get here is it depends. But I'm sorry, it really does.
Okay, thank you. Also, Marek and Peťo, if you wanted to add anything to any of questions, feel free to do it. And I would also like to say that remember that we've got a certain delay during the stream. So if anybody wants to ask any questions directly to Vašek, it's the best time to do it now, so we don't have to wait. Okay. So the second question we have here is from a user called McLocus, I believe, and I will show it, and it says, can you compare costs for a serverless function running at Google Cloud, Amazon, Azure?
I don't, yeah, am I unmuted? Yeah, I don't see why I could not. I think there are some prerequisites that you need to consider, and that is that you have to really know the use case. You have to make sure that it can run on the pretty much same services that you can get on Google Cloud and Amazon or Azure. And bottom line, I don't think there is a great difference when it comes to the services itself. From experience, it's all about how the cloud vendor helps you to, or how it communicates and how it helps you to develop it. So in the end, it really comes to the customer support that you get when you are developing it, because as I said, time is money. And if some great cooperation with the cloud vendor can save a week of work, then it will show. But if you want some concrete numbers, I cannot give them to you right now, but I can, of course, provide them later.
Do you have anything to add, Marek or Peťo?
Not this one, but the previous one about like the language. There's I shared a page on YouTube for the like Google Cloud Client libraries. So these are supported languages. If you want to integrate with GCP, it's best to start with one of these. And then I believe there are also like community libraries. So you can try those, but they are not officially supported. And I believe for Cloud Run and Cloud Functions, you can also find general tips on, cold starts in the documentation, like, for example, how to reduce the dependencies and how to import dependencies when you're doing that in runtime, for example, in Node.js, how to basically pre-cache or not use these dependencies before you actually need them. So yeah, so this is the question, which is low cold start. I believe any languages that's compiled statically will have a cold start. Will have a good cold start, but this really depends on your dependencies, and it also depends on how many services you actually need to connect to before you can serve traffic. So these two things, dependencies and connecting to other services before you can actually serve traffic.
Okay, thank you, Petya. And as we don't have any more questions in the chat at the moment, I will stop sharing this. And I will welcome our second speaker, who is Marek Bartík from Pipetail, and who is going to speak about eRouška backend, serverless golang to serve 1.5 million plus users, and is it expensive or not? So Marek, the stage is yours, and let's mute ourselves, guys, again. Thank you.
Could you just put my presentation there?
Sure.
Okay, hello again. Thank you, Krista, for the intro. And thank you, Lukáš, for the intro to serverless. I wish I knew some of the things before I started working on this project. So you mentioned a lot of useful stuff. Just for the beginning, like my topic is quite clickbaity, as you might see. Maybe that's why you came. Just a little disclaimer. So on eRouška, we have about 1.6 million applications activated, how we call it in the app, or like users registered, but doesn't mean that we have like 1.5 million active daily users. Just I needed to clarify this at the beginning. So, and you'll see that later also in the cost that we have there. So let's get into it. So my talk is going to be really just about one small part of the eRouška backend hosted on GCP. I'm not going to talk about the mobile applications much and all the other stuff that can be talked about. It's not going to be very extensive, meaning I'm not going to talk about the whole politics and adoption and how does it work or not. Maybe you can ask me at the end some of the questions about that, but if it's going to be more about these kind of things, I would prefer answering the technical ones. You can check out eRouška, not only the application code, but also the infrastructure as code in the first repo that's mentioned there. All of this is open source. So the first repo, that's ours, and that's public as well. The second and the third repo mentioned there, it's the joint cooperation of Google and Apple that are doing the whole exposure notification protocol. So the whole API is basically consisting not only from the API on the mobile applications and the support in like iOS and Android operation systems, but also from something that's called the first thing, the notification server, which we also call key server, and the other server like verification server. Basically, the key server is taking care of like ingestion and serving of the keys from the mobile applications, and the verification server is just for like the public health authority to verify some parties in this whole process. Like this is sort of one of the things that is working, for example, when you're like submitting your keys and self-reporting yourself, and also like when you're getting the SMS code when you get tested positive. If you have anything for me, yell at me at Twitter. This is my handle. Like this is a diagram, like the architecture of key server. So this is one of the use cases is ingestions of the keys and a serving of the keys back to the mobile applications. So maybe you're not familiar with the process. So I'm just going to like talk about it shortly. When you have something like eRouška app or any other app, all of these are working with the exposure notification protocol. And let's say that you have the app with eRouška in your pocket, and then you go to a PCR test and you test positive. And then you get an SMS code like, hey, there's the SMS code, and maybe you want to self-report yourself in eRouška. So we like eRouška wouldn't do anything without your consent, but in case you get a positive result, you can self-report yourself in eRouška. So the mobile device or like eRouška is collecting, for example, for the last 14 days, some, let's say, risky encounters. So for example, if you met with somebody or like your phones met and they were near to each other, like less than 2 meters for 15 or 20 minutes or so, then this is considered a risky encounter. So in this case, all of these risky encounters are being like persisted and recorded in your phone, in the mobile application. And if you get a positive test, you can submit these data to the first little box in the upper left corner, and that's our exposure API, it's the exposure endpoint. So that thing is running in Cloud Run. So you would simply upload the keys with a single button click and this kind of thing. Then the keys are being persisted to Cloud SQL, which is Postgres. So far, not super amazing serverless technologies, but bear with me. Then there are other Cloud Runs that are being scheduled. For example, they are like crons that are deleting the keys a couple of times a day. So we don't need to persist all of the keys back 1 year ago or something, but we can really just keep them like a month or 2 weeks ago and so on. And that's one of the crons that are being run there. And the other one is batching. So also a few times a day, we create a batch of all the keys that were being ingested, and we put them in Google Cloud Storage. And that's the bucket that's on the right side of the screen. And then these things can be also like cached in Cloud CDN, and then they're being pulled from all the mobile devices. So on the left side, you just see the part of the ingestion of the keys. That's like a very, very small portion of our users. Those are the ones that are positive, that are actually uploading the keys. And on the right side, you see that those are the 1.5 million or whatever, any number of users that are pulling the keys from this bucket multiple times a day. And so maybe from this, you can already see like that part on the left that's not super serverless, and it's really just like solving like a very small portion of the problem, and that's like something that we would call like the cheap problem. And on the right side, that's the expensive problem, because you have millions of devices just pulling the data from you. So that's going to cost something. So if we would like to optimize something, it would matter to design this right part very well and maybe estimate how much is it going to cost actually. So, of course, if you want to estimate something in the serverless world, you just use a spreadsheet, because spreadsheet, they can calculate everything, right? So from this kind of thing, you can just like look at what's the population of Czech Republic, let's say 10 million people, exposure window of 14 days. So this is what I talked about. Like when your app is recording the risky encounters, it's keeping like a rolling window of 14 days. So 14 days back, there are all the risk counters being reported. If something is 15 days old, it's just going to be trimmed and thrown away. But of course, this kind of input in the equation, it's also it's affecting a lot the final price of the bucket egress cost that we are going to pay. Maybe one thing to mention, like the data that we have in the bucket, like for the storage cost, that's nothing. Like Google Cloud Storage is super cheap. There's not going to be much data. That's going to be cheap for us. But the actual serving, that's going to be quite expensive, or it can be quite expensive. Let's say 15% adoption. That means that the 1.5 million people, as of now, they would be using the app every day. And then you have to count in the new cases that we have daily. And then you can take a look at the actual like underlying data types, like the exposure window and how big in size are the actual keys. Like for example here, 32 bytes, that's how the API is being designed. How big is the daily batch? How many times are we probably going to like pull the data from the bucket? And in the end, you can have something like 2.7 terabytes per day, which is like 81 terabytes per month. It depends on how long the month is, which can also affect the cost, of course. So this could be something like $10,000 a month just for the bucket egress. That's of course probably the most expensive thing, but still it maybe sound like it's quite a lot of money. Of course, we could save a lot of money, or maybe a lot of money with putting like a Google Cloud CDN or any other kind of CDN and caching between the clients and the bucket serving. But for example, with Google Cloud CDN, we would save just like 20% of the cost. So here, like $2,000, which is interesting, but not like super interesting. But just from this kind of thing, I wanted to say that here, really, you can see that the final cost is going to be derived from something like the underlying data types, the exposure window, and also like things like the population. You probably don't want to reduce the population, even though you're sort of doing that right now. But these are all the things that are going to help you calculate the cost for the egress. Of course, there is like fixed egress for the amount of data that you pulled out of it above some free tier and so on. So then this was like a week or a few days after the launch, I believe. And already for the first 2-3 weeks or something, the cost was like 7,000 crowns a month. For all the accounts that we had. Of course, there are some fixed costs for like Redis, Postgres, and all the other stuff. But from here, I would expect that the main, most expensive part is, as we established, is going to be the bucket egress. So from here, you can see that the costs are increasing, but they are not increasing exponentially. So at least we have some time to optimize. Then we want to break down the cost by category like service or SKU. So we really want to take a look at the most pricey billing items that we have in this kind of GCP projects. So we would expect the bucket egress again, right, to be on the first position, but it's not. The first thing is metric volume in stack drive monitoring. Like, come on, metrics, really? This is the most important, or not most important, most expensive part of this. That's weird, right? And if you remember, like from the second slide, so we have some custom backend that we are writing ourselves, and we are also using like the Google developed solution, the open source of the key server and the verification server. And these things, they were using like a default configuration of some Prometheus exporter for Golang runtime. And in the Golang runtime, there was like a lot of metrics that we didn't really need. But the bad thing is that there was like 1% of the metrics that we really needed, because they were the application metrics and we really needed them. And we could either like turn everything off and not have any metrics, or just have everything on. So we had to like collaborate with Google to fix this in the upstream, which still it took a few days before we actually managed to hotfix it and deploy it to production. And also it took us some time because before we actually took a look at the billing. So I believe in the end we paid something like 100,000 crowns for metrics that we didn't need. And then basically we reduced the cost to almost nothing for the metrics. As I mentioned again, the second row is the bucket egress. Here it doesn't really cost much. It was from the beginning. I think in the first 2 days we got almost 500,000 users, but still the price is lower than we expected. So it's a little bit better. And I'm going to tell you some other stuff, some other optimizations that we did there. Then you can see some fixed costs for Cloud SQL, which is the Postgres. Firestore that we're also using, memory store is Redis. And there's one interesting thing as well, and it's the Firebase hosting, like the third from the bottom, outgoing bandwidth. So we are paying something for Firebase hosting. Like, come on, I thought it's for free, right? And so I believe on the 13th, 14th of October or something, there was like an ad in the TV for eRouška, or somebody important mentioned that people should download eRouška. And just for these 2 days, somebody went to eRouška.cz, just like the static website. That's what we have actually in Firebase hosting. Nothing else, just a static website that has some FAQ and maybe like a picture of the members of our team or something like that. still in less than 2 days, there was like 0.5 terabyte of traffic coming from Firebase hosting, even though this has like CDN built in. And yeah, so we paid some money, but it was like 2,000 crowns. Who cares about that? So even though it costs more money than I would like on some kind of like persona pet project, here it doesn't really make sense to optimize it. Maybe at the end, I can tell you something that we had another problem with Firebase hosting like 2 or 3 weeks ago. There was like our first production incident with that, but yeah, the site didn't work for like 24 hours almost. But yeah, this is the kind of thing that we also paid more for just because we didn't know how is it built. So this is something like for the last 3 months, the bill, how much we paid. From here, like December, we don't have all of the data from December because unfortunately, at the end of December, we were switching to a new billing account and we lost all the data. So that's why I'm also showing you the data from October and from the end of December. But you can see here that in January, it was like 1.2k euros. Yeah, I wanted to confuse you more about using euros, dollars, and crowns at the same time. So yeah, sorry. And in February, it was already like 850 euros or something like that. Not so much. So the cost is already going down because of some of the optimizations that we did. The CDN that I mentioned for the serving, that saved a lot of money. And we played a little bit with the caching of the actual objects. So we managed to save much more money with that by making the caching aggressive on just the level of GCS itself. Then we got rid of the stick driver metrics that we didn't need. That saved us indeed a lot of money. But of course, the main optimizing point was, as also Vašek mentioned, you can, when you get rid of the majority of the users, that's where you save most of the money. Yeah. So here you can just see the last 3 months, and the costs now are decreasing, and that's mainly because of the users decreasing as well. I talked about the CDN and how we put it in front of the serving endpoint so that we can cache it more aggressively to save a lot of money on the serving. And then everybody was like, hey, let's put CDN in front of all of the things, right? And as we have some endpoints in Cloud Functions, so for example, as all of these keys, they're being like pulled all the time to all the applications, even when you have it in your pocket and you don't open the app at all, because that's how it's supposed to work. Then we have like a lot of like Cloud Functions for user registrations and some other stuff. For example, the very first screenshot was from the ACTUM statistics, how many people have eRouška activated and so on. So for these kind of things, we have some Cloud Functions and some JSONs or like some data in Firestore. So for these kind of things, we sometimes like take some data, we process them once a day, for example, and then we persist the data in Firestore, and then on demand, when somebody calls this Cloud Function endpoint, we pull the data from Firestore and we show it like synchronously to the client. And it was like, okay, let's put a CDN in front of that, right? It's some static JSON that changes once a day. Let's save some money. But if you take a look in the cloud billing, this thing was costing only like 5.5 euros for the last 3 months. So why would you want to save money here? It's like this thing is just don't over optimize. Always look first on the data or on the cloud billing. Just like here, it would just bring much more complexity into the system. Like don't CDN all the things. So why is this cheap or cost effective? Cheap is a very bad word, I would say. So I would hope that we can all agree now that this thing that is supposed to be like saving our country right now, sort of, that is quite cost effective, because as you can see there, it's like 800 euros a month now. That's a joke. So like if we were about to build something on infrastructure as a service, like I cannot imagine how much would this cost if we were building everything ourselves somewhere in like some basement, or even worse on infrastructure as a service. Like that would be like a lot of data. For example, for the key serving to all of the mobile devices, I cannot imagine how bad and how expensive would it be to even fetch it from something like Cloud Run or a Cloud Functions and pull the data from some database, even a Postgres or Firestore. Like this is just some data that you put in the bucket and you just serve the data with some CDN, and then it's got to be cost effective. Somebody might say it's not cheap, but it's cost effective. So why was this cost effective? I think first is like a very great architecture design. Of course, I'm not talking about the part that we did. I'm talking about Google engineering here, because they designed the whole protocol and they designed that the key server is going to do the serving like this. And that was a very good call. So really, as I mentioned, if it was done like a very naive way, it would be very, very expensive. Of course, we're using Golang, so that has like a very low memory footprint, and we don't have to pay so much money for RAM. We are using Cloud Run and Cloud Functions, so we are scaling to 0 all of the time. If we have some endpoints, like I talked about, not only for the eRouška app, but even in the verification server, when some parties that are using their own verification endpoints, they are not calling them all of the time, and they're sometimes calling them between 9 a.m. and 8 p.m. and so on. And these endpoints are not being used 24/7, and it wouldn't make sense to pay for them. On the other hand, also, we can really accommodate all of the demands that we have. For example, when there's an ad in the TV, we can scale to something like, I believe at one point when there was this marketing campaign, there were like 10,000 registrations per second or more. It was quite a lot. And of course, there are a lot of GCP managed services that we are using, so we don't have to build our own identity access management. We don't have to build our own monitoring, logging. Nothing is in like configuration on infrastructure. We don't have to patch operation systems and so on. So we are using as high level managed services as possible, as much serverless as possible where it makes sense. So with these kind of like serverless, it can be very cost effective, as you can see, or as you could see in the architecture diagram. We don't have to use it necessarily everywhere, but it can be very cost effective. But also from what I showed you, like the stack driver metrics and the other stuff, but don't lower your guard and monitor, or at least watch your billing from time to time, because things can get out of hand very quickly. So now is the time for you to ask me some questions. If you have any, please do ask. And I also felt like I should put something like that we are hiring, but we are not really hiring. Now we don't really need any help with the development of it. But if you want to help somehow, please install the app. Thank you.
Okay, thank you very much, Marek. I cannot see any questions from the audience at the moment, so I will give the spectators a little bit more time, and I will ask Petya and Vasek whether they have anything to add to your topic, or whether they have any question or something. I don't know whether guys are ready.
Yeah. I'm sorry, I'm so perplexed still. No question from me here. But okay, perhaps later on, when it all goes through my head, a lot of useful information that Marek mentioned there. And it's great to finally be part of or see a presentation where you see something like serverless or cloud development in action. And perhaps for people, for international people, if there are any, that eRouška is an application that will monitor basically your mobile phone getting close to another mobile phone, which would mean people being on the crowded place and potentially be affected by the coronavirus. Maybe you said that, maybe I didn't catch that. I'm not sure, but yeah.
I don't know if you mean like sort of foreigners living here or not. But I talk a little bit about like the actual use case. How does it work? How the phones that are staying together, and how or what is eRouška actually doing? Maybe for this kind of topic about foreigners, if you're speaking English here, there's also a thing that we are working on right now, and we are just basically waiting for it to be rolled out for quite a bit. And now it's more like the process, and somebody has to approve it. But there's a thing called EFGS, and that's like a European Federation Gateway Service or something like that. And that's like a cooperation between some countries of European Union. And for example, now eRouška and all these other solutions, they are very local, meaning that now only eRouška works in Czech Republic. But this is an actual protocol, how we are using that. And we can actually like, for example, if I go to Germany tomorrow, I could also like go back to Czech Republic and their own eRouška, like the German eRouška, the keys from some people that were tested positive there. We can get these keys to Czech Republic, and for the people that like came from vacation, they can check against those keys of the people that they met there. And also the other way around. For example, if somebody, let's say French, comes to Czech Republic, that they go back home and they find out that they're tested positive, then we can get this information like the other way around from also again like the French servers, or again like we would send it to France. So this is like a EFGS cooperation that we are solving right now. So fortunately, eRouška wouldn't be just very local for Czech Republic, but it would be a cooperation of at least European Union and majority of the countries there.
I just wanted to say that regarding the metrics billing, I was also surprised by this. And I think like just like don't go with the default settings that there are in OpenTelemetry and OpenCensus and these libraries. We had a project that cost us like €4 for a full month, and then metrics was like €150, just because we used like the default tracing and default metrics on this, and suddenly just grew.
It's also a good point that you mentioned. It's actually I think I said Prometheus, but it's OpenTelemetry.
Yeah.
And this was the default setting, so it's actually the same problem. Yeah. I mean I didn't pay for that, so it didn't hurt me, but it was a tough lesson to learn. But it's definitely the default configuration, and that was quite stupid.
Yeah, and then tracing as well. Like make sure you have like the good settings to filter out messages for tracing, because when you go with like 100% tracing, that will cost a lot, and sometimes you only need like 1%, or maybe for smaller projects maybe like 5% or 2% max.
Yeah, definitely. But sometimes like there's not enough time to figure out what we actually need. But when it's burning the money, it's you find out very quickly what you actually need. Yeah.
And same goes for error reporting, like report all errors through. Yeah.
Exactly. And maybe one important thing to mention is when you have this kind of thing, like you're paying a lot for the metrics, it's very easy to like break it down. For this kind of metrics, there are also like billing metrics in Stackdriver. So you can just like go in Stackdriver, go to the metrics explorer and check there how many metrics are being ingested at certain parts of the day, if it correlates with something else, and where is it coming from. So for example, from this, we found out very quickly that they are like, where is the source of these metrics, what we want to turn off, and so on. So
yeah, I think
it was very, very easy to find.
Yeah, there are metrics for metrics, and then then you can also like exclude logs, I think, right? So you can see in the metrics like, all right, so these logs are coming from virtual machines, like system logs or something, and I don't need them. And it's like gigs of logs, so we can just exclude them and not ingest them at all.
Yeah, that's very good. But we didn't have problems with logs, and we are actually deriving some metrics from the logs, some application metrics for the logs, because it was just easier than to implement it ourselves. And we don't really care about having these kind of metrics like very fresh, because we have them for some kind of like analytics later on. So yeah, we needed these logs as well, and we don't pay for them, so it's fine. So no questions?
Okay, it seems that we've got no questions at the moment. In case anybody had any idea in the future, feel free to write it in the chat and just tag Marek or anything, and we can get back to it later. I will also say one more thing before I leave my word to Petya. And the thing is that in case anybody wouldn't be able to make it until the end of the stream, you don't have to worry about it, because we will, of course, provide you with the recording of today's stream. So it's fine. Okay, thank you, Marek. And for now, I will give the microphone to Petya, who is as well from FlowUp. And Petya is going to speak on the topic of developing on serverless from the cost perspective. So I'm sharing your presentation, and it's yours.
All right, great. I think you can just put my camera next to it as well.
Mm-hmm.
And yeah, thank you for having me here. So again, I'm Peter. I'm a Google developer expert for cloud, and I'm a CTO of FlowUp. And today I want to talk about developing on serverless, but not from much of a engineering perspective. Well, it will be from engineering perspective, but more from a how to not pay for serverless, or not pay for certain things you can do on serverless platforms, like scaling up too quickly and then needing to kind of absorb all the errors that you did, and they will bring your billing far higher than you really wanted, and why you actually started using serverless. And I think and say that Vašek actually told what I was thinking about the whole time I was actually making this presentation, and that is every time I try to do something with like cost perspective or cost optimization topic, I always end up with the same thing, and it's always in the people. Like I think we paid for some disasters, I would say, but more often than not, you will always pay for people much more than you pay for the actual infrastructure. So I would like to start with this idea, and that's the most expensive projects, from my perspective, are built by people who build before they understand things. These for the idea that maybe before we try to build something, we should really understand how the serverless world actually works. And I think Vašek made a very good job explaining how serverless works, and then Marek also showed you some of the things on where the rabbit holes of serverless and where you shouldn't go. And I'll try to elaborate on that a bit more. So I'll start with these two things. As I already said, there are two main categories from my perspective. One is how much we pay for the technology, meaning how much we pay for infrastructure costs and services, licenses, and whatever you try to buy from providers, either cloud providers or SaaS providers or whatever. And then the second, which is far higher and far bigger most of the time, which is time we spend engineering. And I want to talk more about this time we spend engineering, because every time we try to cut costs, we may be cutting costs in technologies, for example, removing some technologies or migrating to technologies that can be sometimes cheaper, but at the cost of spending far more time on engineering, which is bad. What we want to do is we want to transfer to technologies that will help us, pay less, and at the same time we spend far less time engineering on these technologies. And these two categories also have three verticals, and these three verticals, or areas as I call them, are understanding the limits of the technologies that we use, using products, and managing risks. So understanding limits, I think, like, when we look into the serverless world, it's very different from the virtual machines perspective, or the perspective of more general use cases, like for example, databases, PostgreSQL, or VMs. And I would say that these things, when we look at them, these are like Swiss knives. You can basically do anything you want with them. They are kind of like your own PC, so you can just spin up anything. and it will kind of work. It will run forever, and you always pay 24/7. However, in serverless world, this is very different. Then using products, because I feel like this is one of the biggest areas or the largest areas where people make mistakes, is redeveloping or reinventing the wheel, being on the serverless platform, and then instead of buying a SaaS that will cost you like $5, we still have that the need to do it by ourselves. And then the third thing is managing the risks. And this is like from the billing perspective.
We cannot hear you, Peťo.
Yeah, sorry, I'm not sure. Yeah, so managing risks is more about the billing that Mike already showed you, which is there are some risks, and even though you can see the billing every day. For example, for GCP, I'm not sure about other clouds, but for GCP, this will update every day for you, which means it may already be too late, and you may be already spending too much money. And I will elaborate on this later. So let's go into the limits. When we talk about the serverless, we generally talk about the event-driven systems, and I think this is the largest limit that serverless has. It's about you need external systems to actually call your system. You can't have any background jobs or cron jobs inside the serverless applications. You want external systems or your other systems to actually call serverless applications, and these events kind of must be external because you only pay per request, which means somebody needs to make that request first to the serverless. The third thing, and I think this is like the largest thing for me, or I have most problems with this, and it's idempotent events. Why is it important in the serverless world? Is because many serverless services like PubSub will try to retry your messages. Meaning, for example, if you had a bank and there were some transactions, and you'd say, "Hey, I want to transfer 100 euros from A to B," and this message would be retried 3 times, you wouldn't want 300 euros on the second account. You would actually want the 100 euros and the 2 messages to be scratched and not actually applied to the system. And this is very crucial to the serverless, because it's also stateless and it just scales, and you never know when your messages will come to which service. So you may have like 10 services. You don't know that there are 10 services. That's the first thing. And the second thing is there may be multiple messages delivered, and they might be actually the same messages if you have a lot of messages, for example, in your PubSub queues. So with that, I believe these 2 pages should be the first pages you should look into as an engineer. Whenever you try to use anything, any serverless, and especially serverless products, these 2 pages should be your first go-to. The first one is limits and quotas, which means, are we sure that the serverless architecture or the serverless architecture that we have right now will fit properly into the serverless service that we actually want to use? And the second one is the pricing good enough for us? Because sometimes, many times this is like a yes, and for most of my projects and for most of the projects that I contributed to, I could fit everything or nearly everything into the serverless world. But there are certain occasions where you just need to spin up a virtual machine or a data flow pipeline or anything like that, which is not very serverless, or you will still pay for example, a streaming pipeline 24/7. But you need that, and it's far better to use the other service and pay for the other service than go full serverless and patch things and try to do things all serverless, and then ending paying far more for the serverless infrastructure than you would pay for the streaming pipeline, for example. And if you do that correctly, this is one of our development projects. It peaks in production at around 2,000 to 3,000 doc reads and 800 doc writes. It costs us in these peaks, like during the peak month, it costs us around $40 per month. It was like tens of millions, maybe like 60 million reads in Firestore, something like $1.5 million rights in Firestore. And this whole solution for 1 month cost us in the serverless world, because we were able to fit the solution into the service, into the serverless services, cost us around $40, while the MongoDB Plus virtual machine alternative would cost us around $300 to $500, which is 10 times more. And I think this also answers like how much more would eRouška cost if it was like full infrastructure as a service. The second thing is using products. So why I want to do this in the serverless world is because serverless, I believe, was first made to kind of create and connect services that already exist, and then put some engineering value on top of it, which means you really want your event-driven or your serverless services to be kind of like an event hub from other services that you use that are doing the heavy lifting, while this one service that you have, or these multiple services that you have, will kind of connect all the things together, then schedule something or do something, or put something into the database, but not something that I would call heavy lifting. This is also limited, for example, by Cloud Run by 1 hour timeouts, so you can't really run anything for more than 1 hour. PubSub is for like 15 minutes timeouts maximum as well. So you will need to really look into those, and I really suggest you look into the quotas and limits page at first when you try to use the product, because you may just end up hitting the limit and not knowing what to do with that, and just migrating from the product. What you can do, however, with the serverless is you can offload the long-running jobs, background jobs and scheduled jobs into other products that GCP has. For example, if you want a cron job, it's far easier on Cloud Run or Cloud Functions to use just Cloud Scheduler, which is a fully managed cron tab. Or if you want something like a scheduled task, you can just use Cloud Tasks. Or if you want a distributed task, you can use PubSub for that. But there are other services, and there are other services that GCP doesn't have, and you will kind of want to buy these services like MailChimp or SendGrid or these services. And I always say that when you buy services, or when you try to replace something that you would otherwise engineer by yourself, the quality metric for these services is almost always observability. And why observability? Is because when you have the ability to look and see what's really actually happening inside, what are the bottlenecks, what limits you're hitting, what quotas you're hitting, it's far easier to debug these things. And then in turn, it will cost you less on the engineering time. So when you look into this, like this is a infrastructure or architecture that you would otherwise put into one single VM, right? Everything that's in the middle, this is from the cloud block. So you now have 4 cloud runs that would otherwise fit into a single VM. However, a single VM is not scalable, while this is very resilient and very scalable solution. So you always have this kind of trade-off in the serverless world, where you kind of need to manage multiple things, but at the same time, most of the things are managed for you by the cloud provider, for example, by GCP. And then you only have like a small pieces of a code that are connected together. And if these messages are also idempotent, which means you can just repeat them and retry them if they fail, then this is a very resilient architecture. While if you had one VM, you would be very prone to like not scaling well with this. But why observability? And I already started with the observability talk. Generally speaking, I really believe that instead of using the billing that Marek showed you, or I showed you as well, the billing tab, you should be using the metrics as well, especially for services that you're using heavily. And this is because the metrics are updated sometimes every minute, sometimes every 2 or 3 minutes, while the billing is updated every one day, I believe. So while if you have, for example, a Firestore reads, and you shouldn't go over 800 reads per second, you will just place an alert on that 800 mark, and you will get notification from the alerting or from the monitoring and alerting system of the GCP, instead of getting that alert after 1 hour at least from the GCP billing that, hey, you just passed the mark of 200%, of your billing. So whenever you can just, every GCP product comes with metrics. So I believe you should always monitor or create monitoring and alerting for all your products that you use from the start, which means before or immediately after you deploy your first deployment, you should go into that monitoring and alerting and just click on some metrics explorer, create some charts, and make sure that you have alerts for everything that you use. For example, Cloud Run and requests. If you expect, for example, 20 requests per second max, you can just place the mark on 20 per second, and then get an alert if something goes wrong. Sorry. And as well as Firestore, for example. This is like a big thing for many people when using Firestore. We seem to be, the pricing is scary because it kind of scales itself, and you pay for document reads and document writes and document deletes, which makes it very scary. But you can also place these alerts in the monitoring tab there and say, hey, if this goes over, I don't know, 20,000 or 50,000 reads per day, or if this goes over 1,000 requests or reads per second, then send me an alert, and you can immediately start doing something with that. Regarding these metrics, when we placed the alerts there, we got these alerts, and I believe you should pick the value that triggers the alert first and then tweak it. So you know that you just didn't place some very high value that will never be triggered even there is an incident. You should always start somewhere low and say, all right, this was triggered, but it was a normal traffic, so make it higher. This was triggered, make it higher, and so on and so forth. So when you want to start using monitoring metrics, as I said previously, there are metrics for metrics. So you can, for example, say, hey, give me an alert when my monthly log bytes ingested is about, I don't know, 200 gigs, which would mean, for example, 100 euros, I believe, right now, according to the pricing. So when you want to say, hey, I just want to pay, for example, 50 euros for the monitoring, and then after that, we'll probably need to do something with that because that's normal to pay more for us. Then you can just place this alert there on the monitoring, and it will alert you as soon as you will get past the mark. So I'll wrap this up. First thing, read the docs, understand the limits, understand the pricing. Second, use products with built-in observability. It's very important to use products that actually give you some metrics that you can observe what's really happening inside them, and kind of connect these metrics to your own systems, so you know that, for example, when some errors are in your own system, they correlate to errors in other system. So you don't need to you don't need to worry about your own system, because these errors actually came from the different system that has some issues. And the third thing is create monitoring alerts and tweak them manually. Don't be afraid of this. I was always afraid of creating monitoring alerts first, because I was always like, what value should I put in? But you could just put in any value that's low to trigger it, and then see what's really happening there. And after some time of being on that value, make it higher or lower. The one thing is always try to go back to these at least, I don't know, once per 2 weeks, once per month, if you really have a production project, and tweak the value. You may even go, lower or higher based on what you see in the monitoring in the past and what you expect in the future. So I think that's it. If you want to contact me, there's a Twitter, or I will stay here as well. If you have any questions, then please put them into the chat. And thank you.
Okay, thank you very much, Petya. We don't have any questions in the chat at the moment, but I registered that guys have something on you. So Vašek, Marek, it's yours.
Again, I don't really have a question. Just I'm really glad you mentioned the alerting issue. And for example, even if you have a simple app that might probably run on the free tier, even then you really want to set up the billing alerts, because you probably want to you really probably want to remain it the same way, right? To be in the free tier. And the easiest thing you can do is to set up a billing alert to $1 spent, and worst case you're going to pay $1. But yeah, without it, you might get, unfortunately, a lot of people using your app, so to say, unfortunately. But yeah, you would have to pay for that, and that's probably not what you want when you are relying on the free tier of, for example, the Firebase, either Functions or the 5-star.
Yep, I think like the billing alerts and the budgets set in GCP are like the first step that anybody should have on any project, on any billing account. The second step is then using the monitoring as well to have these alerts, because I believe the alerts right now for the billing for many metrics are per hour, but for many metrics also are per 24 hours when you use the billing alerts. While if you use the monitoring alerts, then you have that in the period you set up. So it can be, for example, 5 minutes.
Mm-hmm.
So I would also have a question about the billing alerts. I'm not really sure, so it's more of a question then. Like, I don't really want to mess up with maintaining alerts on the billing and trying to set up some thresholds and tweak the thresholds all the time. So I'm not really sure if GCP has something like a billing anomaly alerts, because as I said, I don't want to tweak the thresholds all the time. Like this is supposed to cost 100 euros a month, and then next month, okay, it's 120, so I'm probably going to give the threshold to 150. And I would just end up just tweaking these all the time. So is there something like a billing anomaly alert on GCP? Or?
I mean, what I would do is I would you can really export your billing data into BigQuery. That's the first thing. And then you can just run the BigQuery ML on it to predict what will be the cost of your project from the past. And then they would probably give you some anomaly detection.
I think
that's what Tomáš said right now.
Yeah, perfect. Thank you.
Yeah, that's the same thing. Yeah.
We cannot really hear you if you're talking, Kristen. Can we?
Oh, sorry. So I was saying that we've got some reactions, which is great, and we've got a question for everybody, which is, how about denial of wallet attacks? Isn't this more dangerous than, for example, DOS on dedicated machines?
Yeah. If anybody wanted to say something, sorry, I jumped into that, but it is actually a thing that I mentioned in the beginning. With serverless, when you think of it, pay as you go can be a great thing, but it can be a downside exactly at what you are saying right now. So billing alerts won't probably save you. I'm not sure, maybe I'm mistaken, you cannot really say after this amount of million invocations, just shut down the service. But what you can do is remind me that there is some anomaly, as Marek just said, in the usage, and it's going to wake you up in the middle of the night. But yeah, it might save you a lot of money.
I actually believe there was a project on GitHub that somebody did that was actually listening to I'm not sure if it was listening to the BigQuery export, but it was listening to the billing, and then basically deleted every resource on the project. So I mean, I'm not sure if you want that, but if you're like really looking into the money and you're like, I don't want to spend any more than $10 on this, and if I do, then delete everything, then I believe that's not such a like it's not solution, you would need to engineer a lot. For example, if you have Terraform, you could just run Cloud build to Terraform, destroy everything.
I would say that the denial wallet is much more dangerous for the wallet, but not for the actual service. And there are some GCP products that have like sane limits. So not all of the kind of API calls that you're paying for have limits, but some of them do. So if you leak your credentials to the GCP project, that's also a problem. But sometimes you have like limits on the IPs that you can allocate to the actual compute that you can allocate. Even without leaking credentials, you have some internal limits, or like a DOS protection, like that's there out of the box, for example, for cloud HDFS load balancer and so on. And sometimes even when you're like a victim of this DOS attack, you can still talk afterwards with like the vendor support, like, hey, somebody attacked us, and they can look at it and maybe give you some money back, at least in the form of credits, or just they scratch the billing. If it's not your fault, or if it was your fault and, for example, you just misconfigured something, for example, it's very popular if you like call a function and you call yourself from the same function, and in recursion you're just calling yourself, you can end up paying a lot of money for that as well. But there are some limits to this, and that's like so common that you might get the money back for that. And then it's easy to get burned, but it's probably not like you're gonna pay 1 million crowns overnight or so on. It's a good question.
I think even like Firestore and these scary services are kept at like 10,000 requests per second, which is a lot still, but there's a cap.
Okay.
And sometimes this cap is, sorry, go on.
No, you go on. I just wanted to end it up, so.
Yeah, just sometimes this kind of caps are also a problem. For example, if you wanted like a counter in Firestore, and when you like updating or adding some documents or adding users, and you're counting the number of users, that's on the other hand, if you're adding more than one user, you're incrementing the counter more than once per second. It looks like it's just once per second, it's not that much, right? But it's actually the limit of the service. So you cannot really have like a counter just like that in Firestore. So you would need to like implement your own sharded counter, or just use a different database technology for this kind of thing. Even though it sounds like super stupid and simple, you're not gonna do it with this kind of technology. So and this is also like the limits from the other point of view. That's it.
Okay, a new question appeared. So, isn't there a possibility of setting maximum of instances serving given service, which could help against denial of wallet, or it could be considered as contradiction for peak handling?
There is a, like for Cloud Run, you can set this. For Cloud Functions, I'm not aware of that. I don't think you can do that for Cloud Functions, but I believe there are active discussions right now around Cloud Functions and limiting Cloud Function invocations. You can definitely set maximum instances of Cloud Run for this. So you can, for example, set to 1 if you want to. If it could be considered as a contradiction for peak handling, yes, it could be, and that's why I would suggest setting up the monitoring, and then make the behavior based on that. So if you see in monitoring, for example, for like I believe you will always end up in the free tier, even if there is an incident for like 5 or 10 minutes. So if you can just spin up the monitoring really quickly on that alert, see, hey, is this normal traffic? Is this really like, do I really have so many users? Or is it like some attack? And then do something about that. That's still, for me, a better solution than setting up a maximum number of instances. But as well, setting up a maximum number of instances, if you know that you won't have the traffic that you shouldn't, do, for example, 10 or 20, it's completely safe.
I think we've got some reaction from Tomáš here. If I guess right, it's a reaction to the last question. So I don't know whether you guys have anything to add to this reaction.
I think there's something missing in that, isn't that?
I think what he means is that if you wanted to limit the concurrency of Cloud Functions, you can take a look at the GCP quotas. So you can edit and modify your quotas as well for the GCP project.
Yeah.
Okay, thank you. And I have skipped one more question, which I apologize for. Again, by McLocus. Can I disable scaling on a function in GCP when I don't need much performance?
If you mean Cloud Run, then yes. If you mean Cloud Function, I'm not sure at the moment, but I'll look into it.
I think you really need to pay attention when it comes to Cloud Functions, whether you can have an allocated memory of a function. So if you don't need the maximum amount of the memory needed to run the function, then choose the minimum one. But I'm not sure if actually you need to set up the scaling, so to say. So
I think you are able to limit, even with Cloud Functions, the concurrency. And not only that, you could also limit the maximum time the function can run. So it's also very important. Like if your function is supposed to run in most of the times only half a second, you don't really need to have there 15 seconds, because this is one of the ways how to really attack your wallet quite easily.
That's actually what I forgot to mention. Yeah, one of the main things. Yeah, just server side timeouts.
Okay, we also have a reaction by Igor here, which I think is a reaction to what Vojta wrote, if I'm right. So just showing the reaction. Yeah.
I think we went through like Cloud Functions, App Engine, and Cloud Run, which are the major serverless services right now on GCP.
Yeah, it's good to mention Google App Engine. I think it wasn't mentioned a lot here, but it's actually, I think, one of the first Google serverless products.
They say it's the first serverless product in the world.
Yeah, ballsy.
It was serverless before it was cool.
Yeah.
When we are talking here about the maximum concurrency and scaling to zero, it's quite fun that actually a lot of people like think about scaling to zero and scaling unlimited. And then you are like, hey, and what about like for this kind of service having always one replica, warmed up? And then you're like, oh, let's just do that with Cloud Run. Oh, I cannot. But since a few months ago, I believe you can already do that.
Yeah.
It's in beta, I think like now
the quotas for concurrency. The quotas for concurrency were also increased a lot. It was like 80 requests per second, and right now it's like 250. So you can have 4 CPUs and 250 requests per second, which is quite a lot.
We have another question. How configurable is the quota system? Can you set up custom quotas depending on functions caller?
Do you mean if you mean limiting the API? I don't believe that. The quotas are for the full service. So I mean, you can always use. I believe there are some examples for Cloud Run and normal serverless applications where you want to limit when you want to have limits per API key or per person or per some account. And if you want more enterprise solution, then there's RPG. but I believe that starts at something like 3,000 euros per month or something like that. But that's an enterprise solution for like API limiting. And I believe you can also limit the API keys when you create them in GCP console. So if you have like your own API through API gateway, I'm not really sure how was the product called before, then you can actually limit these keys as well. But yeah, you can't do that with Quotas, I don't believe.
Okay. Thank you guys for your answers. It seems that we've got no more questions. And yeah, I would say it was pretty enough for the stream. So I suggest that we could now move to a Google Meet where we can continue with our discussion. So anybody who is interested, like to join us for the discussion, you are welcome, guys. I will put the link to the Google Meet in a second to the chat. So I would say that we can close this up. So I would like to thank to our today's speakers who were Václav, Lukáš. So thank you, Vašek. Second speaker, Marek Bartík, and also our Peťa Malina. Thank you very much. It seems that also our spectators are pretty satisfied with your talks, which I'm really glad. And also, I would like to thank to everybody who came today. Thank you for watching. If you were interested in more of our events, you can follow us on social media where we inform about our events like regularly, so you cannot miss anything. You can also join our FlowUp meetups group on meetup.com, and you can also subscribe to our YouTube channel if you want to. I will put like all of these information to both Meetup and Facebook events, so you don't have to write down anything. And I will also put there the recording of the stream and the context to the speakers if anybody was interested in contacting them personally. So thank you very much, guys. I'm going to insert the Meet link to the chat, and we are going to say goodbye to the official stream. So thank you very much for watching, and see you. Thank you, guys. Bye-bye.
Thank you, Krista, for hosting. Thank you.
Thank you, FlowUp. See you guys.